Hello everyone. We the students of Sona College of Technology are happy to be a part in National Kart Racing Championship. I am Aditya from Team Terasvin. I'll be going to present a small introduction on design presentation of a Team Terasvin. Our faculty advisor Ramesh Kumar, Captain Jagan, Vice Captain Thiruvenkatam, they'll be presenting a few slides later in this presentation. Here's the CAD modeling of a vehicle. By design specification and analysis report, we have listed few of our vehicle specifications. Firstly, vehicle length 2070.1 mm, vehicle width is 1198.88 mm, which is calculated considering the autocross and skid pad test in dynamic events. Next is the roll cage material, which is basically low carbon steel of ASI 1018 type. It is actually less in weight and strong. So we have used here in our vehicle. Next is tube dimension. The outer diameter is 25.4 mm and inner diameter is 21.4 mm. Roll cage mass is 11 kgs. Total mass is 95 kgs. Here aluminum is used in most of our parts, which helps in total mass reduction. The more we reduce the total mass, the more is the vehicle's performance. Next is the ground clearance. Ground clearance is 40.64 mm. This length is which provides greater stability and it avoids rollover while cornering. Battery is lead acid battery. Maximum speed is achieved is 69 km per hour. Brake, hydraulic disc brake, and maximum speed is actually achieved by gear reduction. Next is the steering part. The concepts of steering is Ackerman, and it has 6-bar linkage. Tire we have used is slick tires.
Hello, I am Mr. Mani Bandari from Team Terasvin, and I will be guiding you through the next 33 slides. So, the design methodology that we use in our go-kart is as follows. So, for the preliminary design, to get the basic idea about how to design our go-kart, we made a prototype using PVC pipes and we fixed on the wheelbase and the track weight for our go-kart. And the second step was material selection. We selected materials based on their cost, availability, and their weight. The material was chosen so as to give us advantage in the weight reduction of the vehicle. And for modeling, we did our modeling in SolidWorks software using help from our faculty advisors. And FEA analysis on our go-kart was performed using ANSYS, and analysis was performed on various parts of go-karts like the frame, tires, steering arm, the rear axle, and we performed various iterations. Modifications were made on the design calculations so as to put the calculation within the safe limit after the analysis. And finally, after all the modifications and analysis, the final frame was designed. And for material selection, we had various choices like ASI 1018 steel, ASI 1020 steel, and among all these choices, we choose ASI 1018 steel because of its low cost, better availability, better availability, and better advantages in weight reduction of the vehicle. We have performed various analysis on our frame using ANSYS software. Analysis we performed with front impact analysis, rear impact analysis, side impact analysis, and dorsal impact analysis. So for our analysis, we assumed our vehicle will be at rest, and a dynamically moving vehicle hits our vehicle. So for the front impact analysis and rear impact analysis, the constraint points were applied on the wheel assembly points, and the force was calculated considering the weight of the vehicle with the driver and the maximum velocity of the vehicle. So force that we applied for front impact and rear impact analysis were 60,679 newtons. While side impact analysis, the constraint points were applied on the wheel assembly points of the one side of the vehicle and force was applied from the other side. The force applied for the side impact analysis is exactly half of the front impact and the rear impact analysis. So and for torsional effect analysis, the constraint points were applied on the wheel assembly points of the rear part and the force were applied diagonally opposite on the wheel assembly points of the front part. So the maximum stress, deformation, and factor of safety obtained after this analysis is included in our design report. So, and only the designing of a vehicle isn't enough. We have to put in mind and consider the safety of the driver and the driver ergonomics, how well the driver can interact with the vehicle and operate the vehicle easily. So, considering for driver ergonomics, we have included various factors such as easy gear shifting, so that the driver can shift gear easily, and spacious seat compartment has been provided for the driver, so he can be rested easily and he can rest his foot also easily. And we have used pocket kind of seat for our go-kart, so that the driver won't be thrown out while cornering and taking turns, and enable seat inclination for the driver's comfort also included, and wider vision for the driver, so he can see the track easily and do his driving properly. And for the safety arrangements, we have used a fire extinguisher for the case of emergencies, and roll cage padding was also provided to avoid the shocks and jerks. And reliable access of kill switch is provided in our go-kart. The skill switch is included in within our steering wheel, so that the driver can easily access it when it's in case of emergency. And the driver is also provided with driver suit and helmet to avoid any injuries in case of accidents.
Hello everyone, this is Jagan explaining steering system. We have designed 1:1 ratio with the mechanical linkage, which is low of cost, easy to fabricate, and easy to adjust the toe angles. We have set our steering arm inclination with the geometry with Ackermann geometry, which gives us a good turning radius of 2.44 meter, and we have set the Ackermann angle with 28.5 degree. We have achieved our rolling percentage with a range of 95 to 108%, which gives us a good oversteer angles, which helps us through the autocross and skid pad test. And we have a steering wheel with a radius of 10 inch, which gives the required effort for the driver to turn the wheel angles with the mechanical linkage, and it is easy to turn. And there is a braking system. We have designed with the inboard hydraulic disc braking system, which helps our car to stop the vehicle at efficient distance. We have the master cylinder of 8 mm dia, and caliper with the two pistons of 27 mm diameter. We have a pedal ratio of 2:1, which gives us an efficient deceleration rate of 33.4 meter per second square, which stops our vehicle at 3 meter, so from 40 km per hour to 0.
I am going to explain the upcoming slides. Powertrain. We have chosen Honda's Stunner engine based on the HP and torque in comparison with other engines. It is an 4-stroke air-cooled single-cylinder engine which has a maximum power of 11 bhp at 8000 rpm and 11 Nm torque at 6500 rpm, which has a compression ratio of 9.2:1. We are using the same gearbox system for our car, which has a primary direction of 3.35:1, and these are the gear ratios for corresponding gears, and we have reduced final reduction to 1.76 to attain the maximum speed. Since our circumference of the wheel is small, we need to increase the RPM, so we have reduced the final reduction to 1.76. For muffler, we have designed based on the insertion loss for up to 30 decibels. The unsilenced noise level at 1 meter is 105 decibels for our engine. We have designed for an insertion loss of 30 decibels. For that insertion loss, the body per pipe and length per pipe is calculated as per the ratios given for that insertion loss, and we have used glass wool as an absorbing material, which is less weight and which is available more when compared with other materials. And this type of muffler helps in reduction of back pressure when compared with reactive type, and it increases the performance of our engine. This is our manufacturing and cost summary. In our college, we have many manufacturing facilities to perform operations like cutting, drilling, grinding, milling, shaping and welding. And we went outside for pipe bending and wire cutting for jigs. This is our cost report, and we have estimated the cost for each component, and the overall cost of the vehicle is 70,905 rupees. And we also estimated the approximate weight for each component, and the overall weight of the vehicle is 95 kg, and we reduced the weight of the vehicle by CIE to increase the performance, and this is a chart denoting the weight price distribution for each subsystems. And this is our team criteria. We split the team based on the people knowledge in each subsystem and their interest.
Hello, this is Naveen Kumar J, and here I am going to go on to the next following slides. And there's always a saying, a goal without a plan is always a wish. And as such, I am going to explain the project plan. And here we got the project plan. The era started with the team formation of about 18 members, consisting of third year and final year students from the mechanical department of the college. And next, we have successfully registered in KRC event. And the following, we had a rule book study for about 4 to 5 days. And the following, we had a case study, then review of the designs and review presentations, and we divided the streams according to the convenience of our stream members. And we had a stream presentation for weekends, and then we had a continuous review of presentations of different streams. Then we have done the prototype of NKRC go-kart. Then we had a workshop of about 4 days, which we had a great guidance, and according to the guidance we have just changed our designs and our prototype and all the assembly parts according to the guidance. Then next we have got the virtuals for the online, and we had prepared for almost a week. And then according to the event schedule, we have assigned tasks of fabrication and all that. That's about the project plan. And next, going on to the DVP, the design validation plan. It's nothing but a design according to the customer's satisfaction. The roll gauge stream system, we have designed using the SolidWorks software, and the values were obtained using the impact test using the ANSYS software, and it was acceptable. And the next, steering, brakes and transmission systems were designed according to the using the SolidWorks software, and the desired values were obtained using a theoretical calculation, and it was also acceptable. The next, going on to the DFMEA report. It's nothing but a failure mode and effect analysis. As the name suggests, it's a failure mode analysis. The systems of different streams were studied, and studied for their failure modes, and the effects and causes were also studied, and the description for the failures were given according to the severity and detection and occurrence according to the given criteria, and the RPM numbers were calculated. For RPM numbers were calculated, and the actions were taken for the analysis, and the new RPM number was reduced to the maximum. And as such, for the frame, the failure mode can occur at due to breakage of the frame, and effect may be collision of roll cage. And the RPM number according to given criteria was calculated for about the 120, and the action was taken for the analysis, and the new RPM number was reduced to the maximum of about 48. And that's it about the DFMEA. And here we are about to conclude our presentation for the online virtuals of NKRC. And we are solemnly about to thank our staffs, teammates, and all who played a part and parcel of this part and parcel to make up this event a successful one. And thank you. With regards, Team Terasvin.